Everyone, I'm Lakitasi and from Sri Venkateshwara College of Engineering, Department of Computer Science and Engineering. Today's topic is about curve fitting of exponential form by using least square methods. So the table of contents are curve fitting, least square method, fitting of exponential curve, and an example. So first, what is curve fitting? This is a method of finding a specific relation connecting the dependent and independent variables for a given data so as to satisfy the data as accurately as possible. Curve fitting by the method of least square method. Curve fitting is a method of finding a suitable relation or law in the form of y is equal to f of x for a set of observed values of xi comma yi where I equals 1 comma 2 comma till n. Such a relation connecting y and x is known as empirical law. This relation is most suitable for predicting, estimating the value of y for a given value of x. The method of least squares is as follows. Suppose y is equal to f of x is an approximate relation that fits into a given data comprising xi comma yi where I ranges from 1 till n. Then y dash are called observed values. Capital Yi is equal to f of xi are called expected values. The differences Ri is equal to small yi minus capital Yi are called the residuals or estimate errors. The method of least squares provides a relationship y is equal to f of x such that the sum of the squares of the residuals is least. Different forms in curve fitting by least square method. Fitting of a straight line curve, fitting of exponential curve, fitting of a second degree parabola, that is y is equal to ax square plus bx plus c, then y is equal to ax power b, then y is equal to ax plus b. So fitting of exponential curve, that is y is equal to ax power b. Consider the exponential curve. Now we take the logarithms on both the sides. Then we consider log y base c as capital Y, and then log small a base e as capital A, then b log x base e as b and x. The normal equations associated with equation 1 are as follows, that is summation of y is equal to n into a plus b into summation of x. Then summation of x into y is equal to a into summation of x plus b into summation of x square. Then when we solve these two, we'll obtain the values of a and b. Then we'll have the value of capital A. So from that we'll calculate the value of small a. Then finally we'll substitute the value of small a in the exponential curve. We get the curve of best fit in the required form. Remark is that we can similarly fit the curves y is equal to a into e power bx and y is equal to a into b power x, etc. So let's solve an example to understand this topic easily. So the question is, fit a least square geometric curve y is equal to ax power b for the following data. We have the values for x and y. There are 5 values. So now first let's consider the exponential curve, that is y is equal to ax power b. Then we'll take logs on both the sides. As we know, taking log on LHS gives log y base e, then equals log a base e plus log of x power b can be written as b log x base e. And then we'll substitute the values, like we'll take log y, that is small y base e as capital Y, and so on. Then we have the formulas. Summation of I is equal to n into a plus b into summation of x, and then summation of x into y is equal to a into summation of x plus b into summation of x square. So since there are 5 values, we'll take n is equal to 5. Then the relevant table is as follows in the next page. So from the values given, we have taken the values of x, y, then we have calculated capital X, that is log of x values. Since we have log x base e, that's equal to ln. So we'll make ln 1, ln 2, ln 3, then substitute the values here, and then finally find the summation. Similarly, we find out capital Y, then capital X into capital Y, and capital X square. Now the normal equations become, so when we substitute these the summation values in the equation, we'll have this Then by solving these two equations, we'll find out the value of a and b. So a is minus 0.69315 and then small b is 2. Now we need to find out small a. So for that, we had taken capital A is equal to log A base E, right? So when we shift log base E to the RHS, it becomes small a is equal to e to the power of capital A. So capital A is minus 0.69315. So e to the power of minus 0.69315 value is 0.5. So therefore, y is equal to 0.5. X to the power of 2 is the required curve of fit. Hope you have understood the problem. Thanks for listening.